some transformations, but we've primarily used a coordinate plane. Okay, so we've had coordinates and like reflected in a line or whatever. Today we are doing synthetic geometry, which is geometry without coordinates. And I think it's kind of fun because I don't know if I should say this on a video, but I'm going to anyway. I think like having to mess with the points all the time, it's a little bit tedious, right? But I think this stuff is cool. Okay, so a rotation is a transformation in which a figure is turned. Okay, we need three things for a rotation. We need a center of rotation, which is a point. When you get into upper level math and you're doing things in 3 dimensions, you can rotate around an axis, but in 2 dimensions, we just rotate around a point. Okay? We also need to know which way to rotate. So clockwise or counterclockwise. It's a little bit weird, but counterclockwise is actually the positive direction. So counterclockwise is going to be positive, and clockwise is going to be negative. So if you're going this way, it's positive. If you're going with a clock, it's negative. I didn't make up the rule. If you think about it, that's the way the quadrants go. They go 1, 2, 3, 4. The quadrants go counterclockwise, right? It's because that's the positive direction. All right. So we are going to take point P and rotate it about point O by an angle of 45 degrees counterclockwise. And then we're going to label the rotated point P prime. So P prime will be our image, just to use that vocab again. And point P is our pre-image. We can't have an image without a pre-image. Okay, here are our steps. You need your protractor first. So you're going to put, oops, I didn't mean to do that. I just had too much stuff on here. Whoa. Sorry guys, I'm struggling. I didn't mean. All right, we got it. All right, so you're going to put your protractor on your paper. You're going to put the little middle bit on O, on the point that you are rotating around. See how I have my middle on O? Okay, then you're going to make it rotate the protractor so that your point P is on 0 degrees. It doesn't really matter which side. You can make it work either way. If you're going counterclockwise, you want the degrees to be over here so you can go rotate this way. Okay? If I wanted to go to the other direction, I'd put it on this 0. Does that make sense? Okay, perfect. So how far do we have to go counterclockwise? 45 degrees. So I'm going to count from 0, 10, 20, 30, 45. So here is 45 degrees away from P. And make a little mark. Okay, move your protractor away. So step 1 was find a point 45 degrees from P, turning around O, point O. Okay, now the problem is you can see that P is much closer than that point, right? Okay, so what we're going to need next is to do an auxiliary line. So step 2 is going to be an auxiliary. It can be a line or a segment or a ray. But we just need something straight to connect O and that little point that we made. So go ahead and use the straight side of your protractor as your straight edge, and you're connecting O with a little point 45 degrees from P. So this is your auxiliary line. Now when we very first use our compasses, we use them to copy distances. Do you guys remember that? Okay, so we're going to do that again. I'm going to put the metal tip on O, and I'm going to put my, shoot. Okay, I don't know what I just did. I just messed it up again. Okay, I'm putting my metal tip on O and my pencil tip on P. Why isn't it letting me erase that? Okay, guys, I'm really struggling. Okay, I actually did better at this first hour. I don't know what the deal is. Okay. I don't know what to do right now. It's not working. All right. How much time do I have to figure this out?
15 seconds.
42 minutes.
Okay. Okay. I want that to go away, but it's not going away.
Bye, Ms. Lawrence. Have a great day.
Bye. Make sure you watch this really great video.
Okay.
Okay, so okay, bear with me, guys. We're copying the distance from O to P. Okay, so now I am copying that with an arc. Okay, I don't need that whole arc, so I'm going to erase this part of it. Well, I can't pick mine up and just do it over here. You guys can take it and just do it over there. I can't because it's on the computer. Okay, so you don't have to do it on this one, but the next time we do it, just make a little tick over here. Okay, don't do the whole arc or your drawing will get very messy. All right, so that intersection is going to be my P prime. Okay, just to be clear, it's not this one. That one was the one I couldn't get rid of. Oh my gosh, it's like eating everything. It can't be killed. Okay, it is what it is. So that's my P prime. It is at a 45-degree angle away from P, rotating about 0.0. Everybody good? Okay, sorry that I struggled so hard. We've all been there. Did someone say it's just me? All right, that's fair. Okay, transformation T maps the point P onto a point labeled P prime. This can be written in function notation as, if we transform point P, we get P prime. Doesn't it kind of look like f of x equals yada, yada, yada from algebra? Okay, so this is just our generic description that we're performing a transformation on a point and we're getting an image. Okay, if we want to be more specific, we have notation specifically for a rotation. So in this case, the transformation t is the rotation about point O by 45 degrees counterclockwise. If it's counterclockwise, it's positive. Okay, if it was clockwise, it would be a negative. Okay, here's our function notation. You ready? Hey, can you take your headphones off? Guys, we are going to use a little baby r for rotation because the big R is reflection. They both start with R. What can we do? So baby R for rotation. And then we're going to use a subscript. A subscript is small and low. Okay? So it's going to be down here, little bitty. Okay? We're going to say, I had to draw it big enough where you could see it, to be fair. First, in the subscript, we're going to put the angle. We're going to say positive 45 degrees. And then we're going to say what we're rotating around. So what point did we rotate around? O. Okay, and then we close the parentheses. Last step is to say what figure we are rotating. So we are performing this rotation on point P. So this says, everybody watch, rotate P 45 degrees around O. It's like the whole description in a tiny little compact sentence. Everybody see it? Rotate P 45 degrees around O. That's what it means. Good? Okay, the input and output points of a transformation have specific names. The point P is called the pre-image. That is the input. And P prime is the image. That is the output. Okay, you kind of can see that P is in the X spot if you think about f of x, and x was input. You guys remember that from last year? Perfect. All right, let's flip. Okay, this time we are rotating a triangle ABC, about point M, 140 degrees counterclockwise. So it's very important that you are neat and tidy, because instead of doing 1 point, this time we're going to do 3, because a triangle has 3 vertices. Okay, so we're going to rotate. Can you put that phone away? We're going to rotate all, like away, not down. Thank you. All 3 points are going to get rotated around M. Okay? So let's do our notation. Rotation is little baby r, lowercase r, and then a subscript in parentheses. What is the angle? Is it going to be positive or negative? Positive, because it's counterclockwise. You have one on your homework that's negative, so just be ready for that. So it's going to be positive 140 degrees. What point are we rotating around? M. Okay, close your parentheses. Which point are we performing the transformation upon? Oh, triangle ABC. Okay, so the whole thing. Triangle ABC. That's how you do it. It means rotate triangle ABC 140 degrees about M. Okay, we're going to start with A. All right, so I'm going to get my protractor. I put my center on M. I'm going to spin it so that A is on 0. I am going to count 140 degrees counterclockwise. Not this 140, because that's actually 40. I'm going to go all the way over here and make a mark. Okay, move your compass out of the way. Okay, next, you need an auxiliary line or ray or segment. It doesn't really matter which. Going through M and that little point you just made. Okay, it's compass time. Now you're going to copy the distance from A and M onto your auxiliary line. Oops. Whoops. Oh my gosh. I just want to use this guy. Okay, so I put my metal end on M. What just happened? Oh, there we go. I put my metal tip on M and my pencil tip on A. I just messed it up again. I should just not come to work. Oh, I got it. I got rid of it this time. I did it. It's fine. Okay. I'm going to copy that distance over on that. Not right now. No, take it home. Okay. I'm making this arc. Don't make the whole thing. Just make where it crosses over here. Okay? I just can't do that on my computer. Okay, I just want to know where it crosses my auxiliary line. Does anyone need help? Okay, yeah, make your auxiliary line nice and long. All right, I'm labeling this point as A prime. Okay, who needs help? Okay, we're rotating B. I need my protractor with my center on M. I'm going to rotate it so that B is on 0. Mine isn't big enough, so I'm going to make it a little bit bigger. You can't do that. Ha ha ha.
But ours is actually big enough.
Okay, good.
Barely.
All right. I'm going to go 140 degrees from B. There's my little mark. Okay, I'm going to move my protractor out of the way.
Wait, where was it?
Over here. Yeah, did you already do it? Yeah, you can go. Okay, I'm going to use my auxiliary line. I'm going to go through M and the new little point that I made. Make it nice and long so you have room. Okay, next you're going to take your distance copier, your compass, and copy the distance from M to B. So point on M. Oh, darn it. Okay, pencil on B. Okay, you do not have to make the entire arc. Just cross down here somewhere. Okay, I have to make the whole arc. It is what it is. Okay, and then I'm going to erase the part that I don't need so it's going to look like yours. Okay, that's going to be my B prime. You guys are doing pretty good with this. All right. I'm going to put my protractor back on, centered on M. I'm going to rotate it so that my C is at 0. I'm going to shrink mine down a little bit because it's too big. All right, I'm going 140 degrees counterclockwise from C.
Which one do you use? There's two.
Did I confuse you?
Yeah. I just don't know which one to use.
Well, okay. So if you try to use this 140, is that one, two, that's only 10, 20, 30, 40. You see it?
Yeah.
So you have to use the other one. Okay, there's my new angle mark. Okay, I'm going to make my auxiliary line, connect it from M through that mark I made. Okay, I'm going to use my distance copier. I'm copying the distance from M to C. Where do we put the what? I've been putting it on M, but it doesn't matter. It's just easier if I just put it on M, then I can pivot and make a mark. All right, then I'm gonna do my arc. You only have to do a tick mark. And that intersection is my point C prime. So, we've got the points. What do we still need to draw in? Yeah, the connectors, the sides. So use the straight side of your protractor as a straight edge and draw in your sides. Yeah,
It's connected on this guy.
because you got to draw a triangle.
Let's
yeah.
go. We were done with this for the day.
Why does it keep changing? I want it to be black.
It's funny.
Okay. So the true test to see if you did it correctly is to trace your original on patty paper and superimpose it onto the other one and see if it's congruent. So I'm going to pass out patty paper.